So now we'd like to turn to periodic signals in discrete time. We want to know what is a periodic signal in discrete time and determine whether a signal is periodic or not, and if it is periodic, find the period and the fundamental angular frequency of that signal. A discrete time signal x of n is periodic if it repeats itself. So that is, there is an integer time shift n0 such that x of n plus n0 equals x of n for all n. So that is, after n0 seconds, it starts repeating itself. So at 2n0, it's also repeating itself. The fundamental period of x of n is the smallest such n0, and the fundamental angular frequency is just 2 pi over n0. Again, we're measuring things in terms of radiant frequency. Discrete time signals are not quite the same as continuous time signals, obviously because they're discrete time versus continuous time. But we can see that while it's still true that what's multiplying the n in this case is what matters, it's not true that just a plain cosine is going to necessarily even be periodic. So if we look at these two examples, cosine 4/5 pi n plus pi over 6 versus 3/4 n plus pi over 7 in the second signal, we basically have to see, for the term multiplying the n, we want to know, what value of n is that term equal to a multiple of 2 pi? So 4/5 pi times n for some n has to be a multiple of 2 pi. In that case, it's 5. When n is equal to 5, then we get 4 pi. That's a multiple of 2 pi. And then that's the same as if n is equal to 0. So that's where the signal starts repeating itself. So here, the fundamental period is n1 equals 5. The second signal is not even periodic at all, because if we look at the sequence 3/4 n, regardless of the value of n, we'll never get it to be a multiple of 2 pi. So it's always just kind of oscillating around. So if we have a sinusoid of the cosine omega n plus a phi, remember the phase shift doesn't matter. The frequency omega, if it doesn't have a pi in it, then you should really suspect that this discrete time signal is not even periodic at all. You can see from a plot, here's the first one and the second one signal, and you can see that these signals here are, this part here does not really look like this part here, or even like this part here. So it's sort of seems like it could be periodic if you had like a faster rate or something like that, but it's true. It's sort of, even though it repeats regularly or sort of goes positive and negative in a regular manner, it's not itself actually periodic. So again, here's the same picture. If we have x1 being periodic with fundamental period n1 and x2 periodic with fundamental period n2, then what about the sum of the two? Well, again, we can sort of see how many boxes do I have to stack up such that we get the same, the cycle repeats itself. For example, if n1 is 50 and n2 is 120, then you can see when n is 600, then the boxes finally line up with each other. Otherwise, there's always a slight mismatch adding boxes until exactly at time 600 they come together. And so looking at this, squinting at this a little bit, you can see a connection to the least common multiple of two integers. So let's do some examples. Suppose we have a sum of two cosines. Again, cosine pi over 3n plus 2 sine pi over 8n plus 5. So what's the period of the sum of these two sinusoids? Well, for the first one, we have pi over 3, which if I multiply it by 6, I get 2 pi. And for the second one, I get omega 2 is pi over 18. If I multiply that by 16, I get 2 pi. So the periods are 16 and 6, or 6 and 16. And the least common multiple is 48, so it's periodic with period 48. What about x is cosine n over 4 plus 2 sine pi over 8n plus 5. So same second term. First term we have n over 4. The first term doesn't have a pi in it. It's 1/4 and not pi over 4 or something like that. So the first signal is not even periodic, so the sum of these two signals is not periodic. One last example. What about 2 pi over 5n plus 2 sine 2 pi over 7n plus 5? Omega 1 is 2 pi over 5, and omega 2 is 2 pi over 7. So 5 and 7 are the fundamental periods, and the least common multiple is 35, so it's periodic with period 35. just to try it out for yourself, try these couple examples, a rectified cosine and some sums of complex exponentials, and here these complex exponentials, remember, through Euler's formula, can be turned into sines and cosines. So you can just apply that technique to try and get the same kind of answer that we got before.